Today we're going to be talking about measures of variation. So the first measure of variation is something that you've probably learned before, and that's what we call the range. So the range is the difference between the largest and smallest number in a sample. So for example, find the range for each list of numbers here. So all you have to do is look at the data, find the largest and the smallest data points, and find the difference between the two. So in this case, 42 and 6. 42 minus 6 is equal to 36. All right, and for the next one, our largest number looks like is 200, and the smallest number is 59, so 200 minus 59 is 141. Now the range is one measure of variation that we have. It is quite limited because it only tells us information about the largest and the smallest numbers, and those might not be very representative of the information that you have of all the data points in between. So next we have a measure of variation called the variance. This is the average of the square difference from the mean. Now this takes into account all the data points in between. So unlike range, which only accounts for the largest and the smallest number and can give you some information, variance tells you more information because it actually requires you to work with every single data point. So here is the formula for it. So we have the sum of all x squareds minus n times the average of all the x's, so all the data points squared, all over n minus 1. So just as a reference here, x with the bar over it means the average or the mean, the arithmetic mean. x1, x2, all the way up to xn, those are the data points. And then n is the number of data points. All right, next we have standard deviation. Standard deviation is very much related to variance because it is simply a measure of how far the data is from the mean. It is found by taking the square root of the variance. So I'm going to call standard deviation S, and it's simply the square root of the variance. Okay, we're going to do some examples so that we can practice finding the standard deviation. So here's our data: 7, 9, 18, 22, 27, 29, 32, 40. I'm going to just put this data here on the left. Now we know we need to find each data point squared. So we'll do that first. So 7 squared is 49, 9 squared is 81, and we continue that for every single data point here. Now we know we need to find the sum of all the x squareds. So I'm going to go ahead and sum them all up here, and that's 5,132. And now let's write out some more information that we have. So we also need to know n, which is the number of data points, which in this case is 8. We also need to know what the arithmetic mean is. So take all the data points, x, add them all up, divide them by 8, and we get that the average is 23. All right, so now we can put everything into our formula here. So the sum of x squareds is 5132 minus 8 times 23 squared. Only the 23 is being squared here. And on the bottom we have 8 minus 1. Simplifying that, we get this is about 128.6. Now that's the variance. We're trying to find the standard deviation. Remember, the standard deviation is the square root of the variance. So the square root of 128.6 is equal to about 11.3. So this has a standard deviation of about 11.3. All right, next we have the standard deviation for a grouped distribution. So just like we were finding the arithmetic mean for a group distribution, we also want to talk about the variation within a data set where we can group data into intervals. So here is the formula for that. And you can see here, the only difference here is that we have to multiply the frequency of each times x squared, where x in this case, instead of being the data point, is going to be the midpoint of each interval. So for reference, x with the bar is the mean, x is the interval midpoint, f is the frequency, and then n is still the number of data points. Okay, we're going to go through an example where we are going to find the standard deviation for a grouped distribution. Okay, so you're given all these data points. We've already put them into each interval. You should recognize this from our last example in our last lesson. And then we want to write down the interval midpoints. So the midpoint from 0 to 4 is 2. Midpoint of 5 to 9 is 7. And we continue this. So we have 12, 17, 22, 27, 32. All right, now we're going to take each of our data points, which we are just using the midpoint to do that, and square it. So 2 squared is 4, 7 squared 49, 12 squared 144, and we do that for each midpoint. All right, the next column, we are going to multiply each of those data squared times the frequency. So 3 times 4, that's 12, 4 times 49, 196, and we continue doing that all the way down. Now we know we need to have the sum of all the f times x squared, so I'm going to sum them all up here. That's 9,015. We also know that we need to find, well, how many data points are we actually working with? Well, that is simply the sum of all the frequencies. So adding those all up, we have 30. And then now, we also need to know what the average x with the bar over it is equal to. Well, to do that, we need to find the average of a group distribution. So we need to find what x times f is and divide it by 30. So let's go ahead and find x times f in each of these. So that's 6, 28, 72, all the way down to the bottom. We're going to need to sum them all up. That's 465, and divide it by the frequency. So 465 divided by 30. And that's equal to 15.5. Okay, now we should have all the information that we need to plug in to find the standard deviation. So we found 9,015 for the sum of f times x squared. N was the number of data points, that's 30. That was the sum of all the frequencies. And then we found the average was 15.5. And then on the bottom we have 30 minus 1. So simplifying that, we get this is about 7.89. Again, standard deviation is a way to measure how much the data varies. So the higher the standard deviation, the larger the range of the data. It spans a little bit further. The smaller, then the closer it is to some measure of central tendency.